Okay. All right. Then let's start, shall we? Well, welcome to my presentation. I sincerely appreciate that you take the time to come here and listen to me today. My name is Sari Hussein, and today I'm going to be telling you about DevOps and some of its principles. Let me start with telling you a little bit more about myself. So as I mentioned in the welcome and introduction slides, I am an IT architecture and management consultant. I have a broad generalist profile. I'm practiced in IT architecture, in project, product, and service management. I bring experience from multiple industries, and I do have an alphabet soup of certificates in project management, service management, program management, and of course in Agile and DevOps as well. So this is the agenda of my talk today. I will start with telling you about what DevOps is, and then I will move to cover DevOps business value, and then DevOps ways. And then after that, I'm going to go in depth together with you and discuss one DevOps flow principle. And then from there, we will take it to the DevOps game together with our facilitators, Samuel and Emily. So what is DevOps really? All right. DevOps is a culture. It's a culture. It's a movement that emphasizes cohesion, integration, and collaboration within the organization. So the keywords here are really culture and collaboration. It's a culture of collaboration. It's really not a framework of those framework that you may have used in your organization, and I'm not going to name any. It's not a framework. It's rather, yes, it's rather a collection of principles and practices. And we are going to look at some of those principles together today. All right. So if we look at this picture that we have right here, this is a very common scenario in a lot of IT organizations. On the left-hand side, I do have the Agile development teams, the development. And on the right-hand side, I have the operations team. And as you can see, there is conflict in between the two. They are pulling in two different directions, right? The Agile development teams, they would like to respond to quickly changing landscape by building features, right, and deploying these features to productions as quickly as possible. That's what they are passionate about, development teams. On the other hand, the operations team, what they would like to do, they would like to provide the customer with consistent, stable, and reliable services, right? So competing goals, right? Conflict between the two, and this conflict is typically referred to as the downward spiral. They call it downward spiral, and it's very common in IT organizations. And it's catastrophic. As a matter of fact, it results in slower time to market, right? Reduced quality, increased outage, and an increasing amount of technical debt as well. We absolutely do not want this in our organization. Absolutely, absolutely not. We would like to eliminate this concept. We would like to eliminate this downward spiral. Let me take another picture then, which I really like. So here in this picture, we see another instance or another manifestation, if you want, of the downward spiral. So I have this little cute girl right here. She built the house, right? And for her, the house, it was functioning well when it was in development. And then when people inhabited that house, when it is in operation, it is on fire, went on fire. And she's saying, well, the house works fine in development. It's not my problem that the house is on fire now, right? So this is another example of the downward spiral. Another example of a blame culture in the organization, right? This is a blame culture. It's a perfect example of a blame culture in the organization, and we absolutely don't want this either, right? As we move closer towards the definition of DevOps, I would like us to take a closer look at, at different teams that we commonly encounter in IT organizations. So the first one would be development, right? Development teams. And what is development? Development is basically the people who build the product, right? It could be any product. They build the product. It could be any product. It could be a house. It could be a bridge. It could be a car. It could be a mobile application. It could be a mobile phone, right? So development are the people who build the product. For simplicity, I would like us to stick to the house example for a while, all right? So development are the people who actually build the house. They are the architects, they are the contractors who build the house, all right? Let's stay with that example. It's pretty straightforward and it's commonly used in project management education as well. So let's stay with it for a bit and move on and bring in the other player, which is operations. So what is operations? Operations is business as usual. They are the people who maintain the product in the hands of the user, right? And if we get back to our house example, that would be the people who ensure that you have electricity supply in the house. They ensure that you have TV signal. They ensure that you have internet signal in the house. So that's operations in the house example. The thing here is that people who build the house are quite often not the ones who are going to live in it, right? People who build the house are quite often not the ones who are going to build in it. And if you have been looking around for a house to buy, you may have noticed that some kitchens don't have an oven. They don't even have a space for installing an oven, right? So if that is the case, if the kitchen in the house doesn't have an oven and it doesn't have a space for installing an oven, then it doesn't matter if the operations are keeping the lights on in the kitchen. The kitchen is not usable. It's of no value to me, okay? So this is an example of conflict between development and operations, all right? Good example. Conflict, or if you want, absence of alignment, absence of coordination between development and operations, right? So development, people who build the house haven't coordinated with people who are operating the house. Shall we bring in another player then? The third player is going to be security, right? We do have security teams in organizations, right? And when I talk about IT security, I'm referring to three main attributes. They are confidentiality, integrity, and availability. And they are abbreviated as CIA typically. So confidentiality means that information is not disclosed to unauthorized people. That's confidentiality. Integrity means that the information that I have is complete, is accurate, that nobody is missing with that information. And the third attribute is availability. It means that the information should be available to authorized people whenever they need it. So that's how I would sum up IT security: confidentiality, integrity, and availability. All right, but we have the house example, right? We have elected the house example. So what would be security in the house example? Security in the house example would be to have a functioning, right, alarm system in place. That would be security in the house example. One more time, it doesn't matter if security are keeping the house and the kitchen secure, right? If there is no oven in it, the kitchen is still not usable. It's not providing me with any value, right? So in this case, I have a conflict, right, this time, between security and development. There is complete lack of alignment, complete lack of coordination. They are not talking to each other, security and development, right? So, good. The next player then is QA, and QA is quality assurance. So quality assurance assures the users that there is a quality in any given product, that there is a quality in the product, that this product is going to provide them with value. That's quality assurance. In the house example, I would say they didn't have any kind of quality assurance work at early phases of the project. And that's exactly why there is no oven in the kitchen and there is no space for installing the oven. Quality assurance work was missing at early stages of the house project. Okay. There is one point here that I would like to elaborate a bit more on. For those of you who have background in software engineering, how many of you have background in software engineering? Would you please raise your hand? Okay, fantastic. Then it's worth elaborating on it. So the point that I would like to elaborate on is that quality assurance is different from testing. Quality assurance is something and testing is something else. There is difference between the two. We do know that developers do testing, right? Developers do testing. And what do they test? They test that the product function without errors. That's why they write tests and they run those tests. Okay, cool. But what if the thing that the product is designed to do initially is wrong? Right? What if the thing that the product is designed to do initially is wrong? Then it doesn't matter if you write test. It doesn't matter if it's error-free. It's not going to be of use to anybody, right? So there is difference between the two, and this is important to notice. Okay, you should have quality assurance work in your project. You've got to have a valid business case in your project, and you've got to revisit and refine that business case throughout the project life cycle. Testing does not eliminate the need to have quality assurance work in your project, right? That a product has flown by the tests, it doesn't mean that it's a fantastic product. Right? It might as well be the case that no one is going to use that product. So it's important to distinguish between the two, and it's important to have actually both of them as part of your project work. All right, enough of talk about quality assurance and testing. And if we consider these themes then in front of us, development, operations, security, and quality assurance, these themes, they speak different languages. All right. They have different goals. They pull in different directions. Sometimes these directions are opposing, and most probably they are managed separately. You hear about the security officer, and you hear about the operations, the service delivery manager, right? And you hear about the product owner for Agile development. They are managed separately, all right? And DevOps tries to change that, right? This is the current situation, and DevOps tries to change that by really bringing these teams together, right? By encouraging interaction between these teams, by encouraging collaboration between these teams. And this particular slide, really brings me back to the two keywords that I highlighted around the start of my talk. And the two keywords are culture and collaboration. So DevOps is really a culture of collaboration between these teams: development, operations, security, and quality assurance. Yeah, cool. All right, let's move on then and talk about DevOps business value. In short, DevOps business value is huge, okay? If we consider this report, the Accelerate State of DevOps report for the year 2019. This report has been compiled since 2013, by the way, by a research team led by Dr. Nicole Forsgren. So it's quite trustworthy, I would say. The report studies the impact of DevOps practices on software delivery and performance in different industries, based on data collected from over 30,000 IT professionals worldwide. Right. And in this report, the research team, they categorize organizations across 4 different clusters, as you can see in the picture to the right. So you have elite, high, medium, and low performers. Yeah. The elite performers, they have adopted considerable portion of DevOps practices in their organizations. The low performers, they have adopted little to no DevOps practices in their organization. And the research finding from this report for this year, 2019, is that the degree of DevOps adoption will influence business performance. It will influence business performance. To put it more concretely, the more DevOps practices you adopt in your organization, the better your business will perform and the more money you will make. All right. That's really the gist in this report. To give you more concrete numbers or metrics, if you would like. For each metric, then, I'm going to compare between the elite performers, call them top performers if you want, and the low performers, and I'm going also to mention the business value in this metric. So the first metric that I have here is the frequency of code deployments. To production, yes, to the production environment. And the elite performers, they deploy over 200 times more than the low performers. And the business value of that is, of course, to be able to generate more value for my customers. That's the business value in it. So this is the first metric, frequency of code deployment. The second metric that I'm going to bring up is the lead time from commit to deploy. And one more time, the elite performers are faster, over 100 times faster compared to the low performer. The business value on that, one business value in that would be to be able to quickly respond to competitors. If you have shorter lead time, then you are able to quickly respond to competitors and to the changing landscape in the market, of course. The third metric that I'm going to bring up is actually from the world of service management. If some of you have that background, do we have any service management people among the audience? No, we don't. That's fine. But the third metric then is time to recover from incidents, and one more time, the elite performers are faster, over 2,600 times faster. And what is the business value in this then? Can anyone help me with it? What is the business value in being able to recover faster from incidents in the production? If a disruption happened in the production environment, in the service delivery, what would be the business value in that? If I am faster at actually detecting these incidents and troubleshooting them, what would be the business value?
Downtime costs money.
Sorry?
Downtime costs money.
Downtime costs money. Yes, exactly. And if I don't have time, if I don't have downtime, then this means that I will be able to supply my customers with more stable services, right? So more stable services, more consistent services, and more reliable services. So this is the business value in it. Thank you very much. All right. The last metric that I have here is the change failure rate. And the change failure rate, this metric is really a measure of the quality in the release process. Measure of the quality of the release process. And again, the elite performers are better. They have 7 times less chance at failing at change compared to the low performers, which is really, I would say, a very, very interesting observation. If you look at the slide one more time, the elite performers, they deploy up here. The elite performers, they deploy code more frequently. They have shorter lead time. They are more active. And they have shorter time to recover from incidents. But at the same time, right, they have lower chance at failing at change. It's very, very interesting observation. All right. So to sum up DevOps business value then is to really have coherence, to have harmony, to have better alignment between your teams, development, operations, security, quality assurance. Your business will perform better, and you are going to make more money. That's really DevOps business value in a nutshell, if you would like. We can move on to DevOps ways. So what is this DevOps ways thingy? DevOps ways is a group of principles from which all DevOps behaviors and patterns are derived. And you have these ways right in front of you in this picture. What I'm going to do is that I'm going to pick these ways one by one, explain it and give an example. Are we okay with that? Great. So let's start with the first way. The first way is a flow, right? What kind of flow? Flow, I would like to have fast and smooth, not just fast, fast and smooth flow, all right, of work from development, you see it on the left-hand side, to operations on the right-hand side, and then to the hands of the customer. So that's flow. That's the first way. Fast and smooth flow of work from development to operations to the hand of the customer. All right. What would be a good example of flow? Trying to release every sprint. If your teams are trying to release every sprint, this could be an indicator that you have good flow in your organization. Good flow from development to operations through the hands of the customer. That's just one example. There are plenty other examples out there. So this is the first way flow. That's everything I would like to say about it. I'm going to move to the second way then. The second way is feedback. As you can see, I'm closing the loop. I'm trying to close the loop. So the second way entails fast and constant flow of feedback. Fast and constant flow of feedback from operations to development. Fast and constant flow of feedback from operations to development. In DevOps, as a matter of fact, we not only talk about feedback, but we also talk about feed forward. So we have feedback and we have feed forward, and there is difference between the two. What is the difference? Feedback is more reactive, right? So when the operations team come to the development team and alert them and say, well, a service has shut down due to lack of memory on the server, that is reactive. It's happening after the service has shut down, all right? So this is what we call feedback. Feed forward, on the other hand, is more proactive, right? And one example of that would be the operations team telling or advising or suggesting to the development team that, guys, we are better off install more memory on the server, as a precautious measure. So that is proactive. Okay, feedback is then reactive, feed forward is proactive. And I don't know if any of you here has background in performance management, human resources, performance management. Anyone? No? Okay. All right. But I think it's worth mentioning anyway. So in performance management, right, when you give feedback, then you're rating individuals, right? When you sit with one team member and give the member feedback about his or her performance for the past year, then you are trying to rate that individual. Feedback is more focused on rating individuals. It's more connected really to management and reporting and control. That's feedback in the context of performance management. But feed forward, on the other hand, is more focused on developing individuals. You're trying to develop the team member. You're trying to give guidance to the team member. You're offering mentorship. You're offering coaching. So in performance management, then, feedback is management, reporting, and control, right? Feed forward is more coaching, group dynamics, mentorship, and so on and so forth. Yeah, I believe I have cleared it up now. So what would be a good example of feedback then? Telemetry. Telemetry is a good example of feedback. So if I have a good monitoring infrastructure, right, on-prem or in the cloud, okay, that actually detects incidents and reports them to me to be able to do something about them, then I could say that I do have good feedback in my organization. And this is one example. There is plentiful of examples from different domains out there. That's everything I wanted to share with you about feedback, and I'm going to move to the third way then. The third way is continual learning and experimentation. Continual learning and experimentation. So DevOps would like us to create a generative, high trust culture, all right, that enables people to experiment, to take risk, all right, to innovate and to learn from success and failure. That is the third way. We would like to create, establish, all right, and sustain a culture of experimentation, risk-taking, and learning from success as well as failure. Right. What would be a good example on the third way then? A good example on the third way would be testing for organizational resilience. If you are testing for resilience in the organization on a regular basis, then you would say that you have a good culture of learning and experimentation. And for that, we have Netflix. Yes, we have Netflix. So Netflix, they used to have a tool called the Chaos Monkey. And the Chaos Monkey is basically a software robot. It goes around in the production environment and randomly disables instances. Yes, that's actually true. And actually, they have an array of software robots as such. They are collectively called the Simian Army, right? So this Chaos Monkey is one soldier in that Simian Army, if you would like. It goes around in the production environment and disables production instances randomly. And okay, but I mean, when this happens, of course, then the Netflix teams would like sit together in a blameless kind of meeting, if you would like. They sit and they analyze the failure and see what they can do about, you know, improving their infrastructure, for instance, and boosting their resilience to the next level, increasing their organizational resilience. So that's really a very good example on the third way. Cool. So DevOps ways, the first way is flow. The second way is feedback. The third way is learning and experimentation, continual learning and experimentation. And today, the time permits working only with the first way. So we will only be dealing with the first way. Hopefully, we will cover more aspects from the second and third way in future meetups together with you. And under the first way, I do have a bunch of principles. As a matter of fact, I'm going to sample only one principle from the first way. Only one principle from the first way, and that principle is reduce the batch size. I'm going to elaborate on this principle on a theoretical level to start with, and then after that, we will play a game that is focused around this principle. So, what is a batch size? What is the batch size to start with? The batch size is really a unit of work. It's a unit of work at which products moves between stages in the development process. It's just a unit of work. Cool. And I say that a batch is complete only when it has gone the entire length of the development process, and it's ready to be shipped. When this unit of work has gone the entire length of the development process and it's ready to be shipped, then I say that this batch is actually complete. Otherwise, it is not complete. And when we talk about batch sizes, we may, of course, distinguish between, right, large batch strategy. And this is commonly the case in mass production. As you see these guys here in the picture to the right, they have piled already a lot of stuff on the shelf. That's mass production. That's large batch strategy. And the second strategy would be, of course, small batch strategy, and that's what we commonly encounter in lean production, right? Into your lean. Okay, so I'm going to take an example with you on the large and small batch strategy, all right? And it's going to be manufacturing a mobile phone. So how do they manufacture a mobile phone? You have the steps right here in front of you. So the first thing the production team does is to assemble the motherboard. So they assemble the motherboard and they prepare it with peripherals, right? With connections to all the peripherals. And then after that, you prepare the casing for the mobile phone with the display, speakers, and the camera. And then you install the motherboard into the casing and you screw it in. And then from there, the unit will be forwarded to the camera finishing department. In the camera finishing department, they blow the camera clean and they attach a lens to it. And finally, the unit will be forwarded to the testing department. In the testing department, they test for nearly everything, booting and networking and the camera, etc., etc. So these are typically the steps that are involved in manufacturing a mobile phone. And let's together assume that we have a manufacturing plant somewhere on this planet, and this manufacturing plant would like to manufacture 10,000 mobile phone a day. Okay, 10,000 mobile phone a day. And this is actually a pretty reasonable number for the throughput of many mobile phones manufacturing plants out there. So we would like to produce 10,000 mobile phones a day, all right? And we would like to do that first with large batches, and then we would like to do it with small batches, okay? So how to do that in large batches? To do that in large batches, you go like this. So first, you assemble and prepare 10,000 motherboards. And when you are done, you prepare 10,000 casings with displays, speakers, and so on. And when that is done, you install the 10,000 motherboards into 10,000 casings. And only when that is done, you send 10,000 units to the camera finishing department, most probably causing an overflow in that department. And the camera finishing department will do their job. And when they are done, only when they are done with their job, with the camera, the 10,000 mobile phones will be forwarded to the testing department. The testing department will test 10,000 mobile phones, and only when all that is done, we can say that the batch is complete. 10,000 mobile phones are ready to be shipped. They are ready to deliver value to the customer. How does this sound? What do you think about this strategy? Risky, right, very risky. How about small batches then? How to go about manufacturing 10,000 mobile phones using small batches? You work with batches of up to 5 units at a time, basically. So you've got 5 motherboards, 5 casings, install 5 motherboards into 5 casings, and then send 5 units only to the camera finishing department, which is a pretty manageable number of units, right, to work with at the same time. And then when they are done, it's forwarded to the testing department. They will test 5 units, and right there you will say, oh, I can deliver value now. I have 5 mobile phones that are ready to be shipped, are ready to deliver value. This sounds way more sensible, I would say, when compared to the large batch strategy. Okay, this is really the case in most mobile phones manufacturing plants. In most mobile phones manufacturing plants, they work with batch size in between 4 and 6, 4 and 7, or something like that. They don't work with batches of 10,000. No, they don't do that. No. So now we have discussed the this principle, reduce batch size. I would say at the theoretical level. The next thing for us would be to play a game together around this principle, together with our facilitators, Emily and Samuel. And with that said, I would like to thank you very much for listening to me. And if you have any questions or thoughts, then please go ahead.